Greetings, fellow humans. It's Gay Sarah K back at it again with Human Resource Machine. This is probably the last episode, as I have gone through and already done all of those levels, so there's only these two levels, this level, and this little piece of plot left. Now, sorting floor has been the bane of my existence for a while, but this time, with a little help from a subscriber who is very smart and talented and no doubt quite attractive, I have a Java bubble sort algorithm just kind of sitting here for me to reference while I continue to do this. I also realized stupid little thing about the about all of the inputs is they're always largest, smallest, and middle. So I don't actually need to do the bubble sort for the first input, but that's a separate matter. I will go ahead and set a variable that I will call n. I will set a variable that I will call j. One that I will call temp. And one that I will call swapped. And these are going to be the specific variables that I'm going to be using for this algorithm. Notably for n, I need to actually keep track of, oh, right, one more variable, just to optimize things a bit, j+1. Now, let's see here. I am going to have to set up a, first I have to inbox and copy to there, but first I have to copy from 0 and copy that to n. And actually, I will go ahead and copy that to j, and temp, and swapped, and j+1, which I'll then go ahead and bump, because the whole point of j+1 is that it's supposed to be larger than j. Right. So after that copies to the position established by the variable n, I'm going to go ahead and yeah, that should be the loop that actually copies the values into the array. L O G I C and that value is 5 when it should be 4. So I'm gonna go ahead and also bump -n. Yeah, looks right. Then I will go ahead and copy from 0 and copy it to J. So I guess I don't really need to do any of those. Although I should copy to J plus 1 and then bump J plus 1. I'm going to go ahead and comment that this is the start of the inner loop. And then I'm going to need to compare. So I'm going to want to copy from that position and then subtract that. And actually, if this number is greater than this number, yeah, I'm going to want to actually copy from there and then subtract that. And then if it's negative, then I'm going to want to do something. If it's not, then where do I want to jump back to? Well, because somewhere in here I also need to check whether J is less than n minus 1. Which I think, actually, due to the way that I'm defining in here, I think it's actually going to be... Oh, no. No, what I can do is I can compare J plus 1 to N. That's what I'll do. So, I will copy from J plus 1. I will subtract N. And then, if the result is 0, then then we're done with the inner loop. Which means it's time for the, dang it. I just lost my train of thought. Because if it's 0, then I need to go ahead and get to the very end. Now, if this value is negative, then the value that I'm holding, yeah, I'm going to want to copy from this position, copy that to temp, and then I am going to want to copy from there and copy to there. then I'm going to want to copy from temp and copy to that position. And then I am going to bump minus swapped. Swapped is supposed to just be a Boolean value. It's simply true or false, but we don't really have Boolean values per se. So actually we don't have Boolean values at all. So what I'm doing is I'm copying 0 into swapped, and I am decrementing swapped when I would be setting it to true. And so basically, as long as swapped is negative, then that means that it's been flagged as true at least once. Now, okay, so this is jump if negative. That's jump if 0. So this right here is the if statement inside of the inner for loop. This actually regulates the inner for loop. But once the inner for loop is done, then I need to increase j and increase j plus 1, and then jump back to the part that yeah, I can actually do that. And that is the inner loop. The inner loop should be done. And inner loop. Wait. Because, right, this takes, where's the part that actually compares j plus 1 to n? Right, this is that part. And that says jump if 0. Yeah, that should actually be further down. Oh, I feel like I've completely ruined this already, which is bad. Let me see what this program actually does when I run it. So it grabs the R, compares it to the B. Oh. Okay, so that part's wrong. I did, in fact, reverse the order. No, I didn't. It's just always swapping. Every time. Because this jump if negative is wrong. I think that I'm supposed to have a jump there, and then this jump if 0 is supposed to go there? Is that right? I don't really want these commands here. Because that's just going to make testing more difficult. So it was negative. Now it grabs the 55, subtracts the 91. It's negative. Okay, so the test to see if j plus 1 equals n that needs to be higher up. Okay. I think that's right. Okay. Let's just... Oh. No. No. That's not right. Ugh. Oh, there should be a jump here. And it should go... Yeah, it should go there. Wait. Yeah, okay. I'll say jump if 0, and then yes, that's better. And then I'm also going to need to huh. I see a problem. This is so hard. Our users have been rating some of our hardware products 1 star, with user reviews citing, draws too much power and overheats, numbers are too complicated for test subjects, occasionally removes alarming volume of skin from human users. So management has come up with a solution to make the numbers smaller and easier to understand. I've worked a bit on this one before, but I'm not sure that this solution even works fundamentally. Because, what it does is it simultaneously finds the, And like, for this particular case, it's going to output 0, and management's not going to like that. Oh, no? No. Okay, that's not what the problem was. It actually didn't output 0, which is correct. But... ugh. 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 You know, I think maybe... I don't think this is going to be any better. Because it did jump at 0. But then... I need to... copy from there. Copy to there. Subtract in. Jump of 0 and go like all the way back to the start. Yeah, all the way back to the start. Otherwise, I'm going to want to copy from temp. Well, right. No, because I think I wanna... Okay. Copy from in. No, that doesn't change anything. No. Okay, right. So I take temp, I subtract in. Ah, yes. Now I know, what it was. Because I actually wanted to make that a jump if negative. But temp minus in should be negative, which is why I actually wanted to copy from in and then subtract temp. So then I want to copy from the position indicated by temp, outbox it, bump temp, and then jump back to there. And this is how I will output. Okay. So it outputs the 22, increments temp, does the subtraction, grabs the 44, increments temp, does the subtraction, grabs the 70, outputs the 70, increments temp, does the subtraction, and then it resets everything. Except for J and J plus 1, because those get reset later. That might have been a bit premature. Oh, nope, 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 no. Now this is comparing J and J, the indexes on J and J plus 1. If it's negative, then we actually want to perform this copy. Otherwise we don't, which I think if I make that J and that J plus 1, then I could do that, and then remove that jump command. That should be a little more, slightly more optimal in terms of number of commands, but I think that is actually slightly worse in terms of performance. Primarily because it will actually swap two things that are equal. Which only happens like once and only in some of the inputs, so I guess it's fine. Like we were just looking at the word awake that has two A's in it. But this loop that's supposed to, this inner loop, right? After it bumps J, it needs to jump further back up in the loop. Yeah. Yeah, this jump command isn't supposed to be there. Or... wait, there is supposed to be a jump here. But it's supposed to go back to the outer loop. Which, goes there. And I'm also supposed to copy from 0 and copy that to swapped. But that's actually not good. I'm gonna call this M. And here, I want to copy from N, copy to M, bump minus M. And then, down here, when I'm dealing with the output, I want to use M instead of N. And that should work. So it swaps the T and the H, swaps the T and the I, swaps the T and the N, swaps the T and the K, and then it goes back. No. No. Because after it swaps the T and K, it's supposed to bump J, right? And then that loop is supposed to end. But that is not where that loop is supposed to end at. It's supposed to end there. Yeah, I think that seems right. That's bad. That's bad. I can't... This is 46 lines of assembly. I can't wrap my head around this. Like, jump if 0, jump if negative, these are practically meaningless to me. Okay. So it grabs the B. Well, it doesn't. Right? Because it just compared the B and the R, decided not to do anything. But now that it's compared the R and the A, it's like, oh, well, those need to be swapped. And then the R is going to make the rest of the way down. Okay. So then it jumps back there, bumps J plus 1, copies from J, subtracts in, 0, so it jumps down there. But it actually needs to jump to here. That is exactly where it's supposed to jump to. So it swaps the A and the W, swaps the W and the K, swaps the W and the E. So it decremented in like it was supposed to. And it reset J and J plus 1 like it was supposed to. And now it's comparing the two A's, and it's going to the trouble of swapping them despite the fact that that's not something that really needs to be done, but I did that to reduce the number of commands I needed to give. And so now it's going to compare the A and the K, decide there's nothing it needs to do about that, compare the K and the E, decide there is something it needs to do about that, go ahead, put that down, make the swap, decrement swapped, right, and so then it does this, makes this comparison, that's 0, so it goes ahead and copies 0 into swapped. It should reset J and J plus 1, and it then goes ahead and makes that comparison. Oh, crap. Okay, that's bad. Okay, so that's actually really bad, because it goes ahead and marks it as swapped, despite the fact that, you know, those two values are the same. And so it will continue to run through this loop of comparing values until eventually it hits the point, well, until it eventually hits this point. So then it does A, E, K, W. But this is going to be a lot of cycles. Way more cycles than should be necessary. And this time we have a 10-digit input, which is a lot. A lot. And this particular algorithm takes a long time to do longer inputs. I mean, it takes a really long time. I know faster algorithms, but they require, like, extra memory and stuff that, you know, are just... I mean, okay, even insertion sort is better than bubble sort, but, like... This is a lot of cycles it's going through right now. And, like... Well, that says N is still, like, N is already down to 7, so that's actually decent. Sure enough, 93 is the highest value, and 89 is the second highest, and 74 is the next one. But, you know, it takes a while. It starts by finding the highest value, putting it over here, and then the second highest value puts it here, third highest value, and it just continues to do that until it eventually runs out of values. Right, this 30 is very slowly making its way back here. Oh, this 17 actually is very slowly making its way back here. And you see N is now 2, and every time N goes down, this process gets a little bit faster, but it has to repeat the process for every single value of N. And so, like, if N is 3, then it has to do the process 3 times, but the process is also... Yeah. So I did it. I did it. And it took 46 commands. And it took 1,190 steps. Not good. But I did it. And that is good. So now I can continue to the elevator and finally see what's through here. You're 42.
Congratulations. You've really become an invaluable instruction follower.
Yes, don't worry, your job is safe. We've replaced you with this electric box.
It's called a computer. It iterates through a list of simple instructions, called a program.
It has a small amount of memory to store data while processing, like tiles on the floor.
It has inputs
and outputs.
Its simple instructions can be used together in infinite combinations to compute just about anything you can imagine.
A truly efficient worker that never sleeps.
It's going to change everything.
Please take your things and enjoy whatever it is you people do out there. Congratulations.
there we go. And that was Human Resource Machine. And I think I'm just gonna not do these. Like, sorry, but like, no. Just, no. I think I'm done with this game. It's been fun, but I'm done. And that was a rhyme, and I'm out of time. So, you know, this has been Human Resource Machine. If you enjoyed this video and would like to see more content like it, like, subscribe, comment, all that jazz. And if you didn't enjoy the video, like anyway. I could use the publicity, and I'll always come out with something different later. And as always, take care, and I will see you next time.